This equation is an example of a time that you're going to use both your specific heat and your molar heat of vaporization. So we're going to evaporate this liquid. We started out with liquid, we're turning it into a gas. So that means that we need to use our delta heat of vaporization, and we need to use our Q equals MCAT equation. To start with, we need to get the water to boiling. That's not the same as evaporating. We need to get the water to boiling, which means we need to increase the temperature to 100 degrees Celsius. So I'm going to plug this into my Q equals MCAT equation to figure out how much energy we need to make that happen. 18.2 is my mass. My specific heat of water is 4.184. And my delta T, my change in temperature, I need to go from 75 to 100, so my change in temperature is going to be 25 degrees Celsius. I'm going to put all of this in my calculator, and I get 1903.72. And my units for this, because I'm looking for Q, my units for this are going to be in joules. Now, all I've done in this equation is figure out how much energy it takes to get the water up to that temperature, but I have to use delta heat of vaporization to figure out how much energy it takes to evaporate the water. So right now this water is boiling. I need to plug things into my delta heat of vaporization equation to figure that part out. So I'm going to plug in my delta H vaporization for water, which is 40.6. The mass that's given to me in this equation is 18.2 grams. And the molar mass, which I'll find from the periodic table, is 18 grams. So my delta H equals this. I'm going to put it in my calculator. And I got 41.05. And that's in kilojoules. So now to figure out how much total energy this is going to take, this is the amount of energy it takes to raise something, to raise a liquid to a certain temperature. This is how much it takes for it to actually evaporate. So I'm going to have to add these two together to figure out how much energy is required to evaporate that much liquid. So I actually need to change this to kilojoules so that I can add the two of these. This will become 1.90372 kilojoules, and I'm not rounding just yet. So I'm going to add these two things together. They're both in kilojoules. And I get 42.9548. Remember, you don't look at temperature to count sig figs, so I'm going to look at the mass for sig figs. This should become 3 sig figs. So it needs to be 42.9, 43.0, either of those would be close enough, and my units are still kilojoules. All right, if you guys have questions about this, let me know.